Hey guys, let's discuss new problem from system design, new concept from system design, which is called consistent hashing. So in consistent hashing, what we do, let's say you have a okay, you have three servers, S1, okay, S2 and S3, and let me give numbering to this S1 is 0, 1 and 2, and then you have a three request, let's say R1, R2 and R3. Okay, and there is one key associated with each request. So let's say key for this this one is 100, for this is 200, for this is 300. Okay, now I need to map these requests to these servers because let's say my application is handling millions of requests per second. Okay, so I would be required multiple servers. One server cannot take a load of all the requests. Okay, so I have a formula, hash key, okay, hash key mod n, where n is the number of server. So using this formula I can determine that which request will go to what server. Okay, and let's see, this hash key is again one more server. This is expression. Okay, and then this hash key is I have a function. You can write any logic here. I'm writing it like 10 into key. It will return me 10 into key. Okay, and plus 1, let's say. So 10 into key plus 1. So key is 100, 200 and 300. So when I find the hash key for this R1, what it would be? 10 into 100. Okay, what it would be? 10 into 100 plus 1. So it will be 1001. Okay, 1001. For this one, what it would be? 10 into 200, 2001. And this one will be 3001. Now using this expression I will find the number, the server number. Okay, so 1000 mod, what is n here? N is 3 because you have 1 2 3 servers. Okay, so mod 3, 2001 mod 3, 3001 mod 3. What will be the answer? The answer will be 9 0. So 1 will be here, and here 2 1, 0 will come here, and here 1 will come here, right? This could be anything. So it means that R1 will go to S2 because 1 is associated with S2, and R2 will go to 0, and then this R3 will go to again S2. Okay, my hash function is not that optimized. That's why all the requests are going to S1, S2. Most of the requests are going to S2. Okay, if that is optimized, then I can fully reuse the all three servers. So that is the different thing. But right now everything was fine. Okay, working fine. But the problem will arise when I will add new server or I will remove new server. Why? Because the value of n here, this one will get changed. If this n will get changed, then all the expression, okay, all the calculation will get changed for the request. Because here instead of 3 4 will come, right? Then the mod value will get changed, and then we need to remap request. And then similarly if I remove the server, so this one instead of 3 it will become 2, and then again I need to remap the request. So what I want to design a system where I need to do less reshuffling, okay, of a mapping. So what I can do, very simple, I will create one hash ring, consistent hashing. So I will create one ring here. Okay, I will create one ring here, and then I will place my servers on this ring. So let's say this is S1, S2 and S3, and what I'm saying that I have a range here. Okay, from here, let's say I'll take different color. I have a range from here to here. Okay, all the requests will should be catered by this S1. Okay, in clockwise direction next server, and similarly for all the requests which is falling under this range S1 to between S1 to S2 should be catered by this S2, and similarly for S3. Here if I add new server, okay, now let's see what will change. Request from here to here will not get changed. Okay, only request between this let's say this is S4, so request between this S3 and S4, it will get changed. Earlier it was going to S1 server, now it will go to S4 server. That's it. And similarly if you remove any server, so let's say you have removed this S1, so all the requests which were going earlier to S1 will now go to S2. Okay, but now here problem is, so this is very simple. You don't need to reshuffle much request. In in minimum reshuffling you are able to add or remove the server. Okay, but now here one more thing, the load distribution. Okay, let's say all the requests are falling under this range. Okay, so all the load will go to this S2. right? But that should not happen. So what we can do, you can create a copy of a server. Let's say copy of s2 is s2a, which I'm placing here. Okay, this s3, copy of s3 is s3a, I'm placing here. For this s4, I'm placing here s4a. You can create multiple copies, you can place them in a hash ring, okay, in a ring, any location, so that all the, let's say now if the request is falling here under this range, so it should be catered by s2a and not to s3 directly. Okay, so with this, what you can do, first of all, you can do the load distribution, and second, if you have a very powerful server, you can create a multiple copies of that server. Let's say s4 is powerful, so I will create 3 copies of s4, and s3 is not that much powerful, so I'll create only 1 copy of s3. Okay, so this is also you can do. So this is the concept of consistent hashing. Now let's see the theory part. Okay, whatever I have just described you, we will just see that in a theory part. So what is this saying? Imagine you have a system of 100 servers and you add one more server. So should all the data reshuffled? Yes, correct. This is the problem with consistent hashing. Okay, now what was the traditional hashing? So let's say you were finding server index using some hash key function mod n. Okay, now if n changes, almost all keys will get remap. Okay, and which is causing heavy data movement. So now the core idea here is map both keys and server on a circular hash ring. That is called hash ring. Okay, now hash ring visualize a circle from 0 to max, and servers and keys are placed in this ring. Each key, what is the mapping rule? So each key maps to the next server in a clockwise direction, and if you add server, so only keys between previous server and new server will get moved. Okay, other will get unaffected. Similarly for remove also, keys move to the next server clockwise direction. Now what is the problem with this? So here uneven distribution of the server. So for that we saw the virtual nodes. Okay, copy of a node. So each server appears multiple times on a ring. Load balancing, more powerful server will get more virtual nodes. Okay, this is also we have discussed. Now what is the complexity here? For adding, removing, okay, and for checking a server lookup, the complexity is order log n here. Okay, you are not going for the entire changes, only log n. So in interview you can say that minimal data movement, better load balancing using virtual nodes. So that's it, and this is the diagram for the consistent hashing, basic consistent hashing. So you will have a keys, you will pass that key into the from the hash function. It will give you some value, and that value, using that value, you can place your request in a hash ring, and then the next clockwise direction server will cater it. Okay, so that's it. Thank you.